All right, 3.5 is super duper duper short. That's why we're doing it with 3.4. They're both kind of independent. This one, I'm gonna give you a little bit of notes, just this one example. So pause me and just write this stuff down. Okay, now the first thing is we need to have the one side of the inequality to be 0. So a lot of the problems on the homework, you're gonna have to move some stuff around so that one side of the inequality is 0, okay? Once you get it set up like that, this is now in standard form and we can factor. So yay, more practice with factoring. So what multiplies to -12 and adds to -4? Can't write and talk at the same time yet again. Okay, so that's the first step. This is a quadratic inequality. So anytime, the only thing we've solved with inequalities prior to this subject, which I believe you guys learned in Algebra 2, I'm trying to remember. It's been a couple years since I've taught Algebra 2, but whenever the first time you learned it, prior to that, the only thing we ever solved with inequalities before was linear, meaning degree 1. So anytime the degree is higher than 1, we have to go through the method that I'm about to teach you right now. So the first step is to make it equal 0, or one side is 0. Okay, if you want to write the steps off to the side, that might be a good idea. Just make sure you're pausing as you're going. So get one side equal to 0, then factor. Okay, sometimes you're going to have to take out a common factor first. Sometimes you're just going to go straight to the factoring. Next thing is to find the key numbers. That's the values where this thing would equal 0. Those are called key numbers. I'm never going to test you on that, but I am going to refer to them as key numbers. So it's a good thing to know probably. Okay, so what would make the polynomial equal to 0? Those are the key numbers. Those key numbers I use on a number line. Now make sure you put them in the right order. Smallest is on the left, okay? Now I'm imagining I'm chopping this number line at those spots. So I have the piece to the left, and then I'm chopping, I have the piece in the middle, and then I have the piece to the right, okay? Now I'm gonna pick some test numbers. So anything to the left of -2, anything on that first piece, I'm going to pick the easiest number I can think of. I could pick -756 if I wanted to, as long as it's to the left of that first key number. Anything in the middle, I can pick any number I want. I can pick -1.64789, but I'm going to pick 0 because I want to pick the easiest number. And then anything to the right of that key number. So I'm picking a test number at each spot that the key numbers broke the number line, okay? So I broke it into 3 pieces, left of my marker, in between, and to the right. And then I'm going to take those and plug them in. And I don't care about the numeric value. All I care about is the sign. So if I take a -3 and plug it into this first parenthesis, do I get a positive or a negative? I get a negative, right? Specifically, I get a -9, but I don't care about the quantity. I just care about the sign. And then if I plug a -3 in right here, I also get a negative. And these are being multiplied together. A negative times a negative is a positive. I'm going to do that 2 more times. Plugging in a 0 in the first parenthesis gives me a negative. Plugging in a 0 into the second parenthesis gives me a positive. And a negative times a positive is a negative. One more time. Plugging a 7 into the first parenthesis gives me a positive. Plugging a 7 into the second parenthesis also gives me a positive. And a positive times a positive is a positive. Okay? Most of the time, these number lines will alternate. However, I am always pretty aware of making sure I find one for a quiz or a test that does not alternate, because I don't want you to just get this one and then assume it's going to alternate like that. All right, now what is this telling me? This is telling me that any number I plug in to the left of -2 or less than -2 is going to result in a positive number. Any number I plug in between is going to result in a negative answer, and any number to greater than 6 is going to result in a positive. This is asking me for this thing to be less than or equal to 0. Well, that would be negative, wouldn't it? Less than or equal to 0 is negative. So I want to include in my answer anything between -2 and 6. It includes an equal bar. In fact, I'm going to do this in a different color to emphasize it. The inequality includes an equal bar, so that means I can use brackets. If this didn't have an equal bar, if it was simply a less than, I would have to do parentheses, okay? So now let me look at the graph of this, just as a review. So this is kind of like a numeric solution. I want to look at a graphic solution because it's going to help you really see where we are, okay? So looking at this form of the polynomial, looking at this one, the factored form, we just talked about this not that long ago. I can see that the x-intercepts are 6 and -2. It's a parabola because it's a quadratic, right? I know it opens up because a is greater than 0. Oops, sorry, you can't see that. I could also find the y-intercept if I wanted to. So this was the x-intercepts based on what we talked about with that Desmos card sort thing. The y-intercept comes from plugging in 0 for x. And looking at this form, remember we talked about this, plugging in a 0 for x gives me -12 for the y. So I just want a sketch of this. I don't particularly care how beautiful it is. I'm going to say this is -2. I'm going to say this is 6. And I'm not going to have this be to scale because it's just a sketch. 0, -12. I know it opens up, right? So I'm just going to like sketch. I really don't know what this looks like, but all right. So now what I'm looking at is this inequality is asking me, where is this thing negative or equal to 0, right? Well, what's negative mean on a graph? Imagine that now I'm talking about y equals, because if I'm talking about a graph, I need an x and a y, right? Y equals, well, this is saying where is y less than or equal to 0? Well, doesn't that mean below the x-axis? Below the x-axis, less than or equal to 0. That's the less than part. The equal part is on the x-axis. Less than or equal to, okay? So if you look, the graph is below the x-axis, all in here, right? And it's on the x-axis right here and right here. So from what x values is this true? Well, look, -2 to 6. That's the answer that we got before. Okay, so there's the visual for this algebraic solution. So there's a couple problems where they give you a graph on the homework tonight and they ask you to interpret the graph like this. The majority of the problems are like this where you're solving them algebraically. One last thing, I need you guys to write this down. This is for 3.4. You guys are going to do some reading on your own for 3.4 and then there's some applications, but there's one problem that asks you for quadratic regression. For the quadratic regression problem, you're going to go into your lists like we've done before for linear regression. So you hit stat edit, right? So for lists, you hit stat and then edit. I don't remember if that's all caps. I don't think it is when you get into the stat menu. And then you're going to go back out to do the actual regression. You're going to hit stat, calc, quadratic, quadreg is what it looks like. Okay. All right. So hopefully that's enough for that because we've done the linear regression already. And if not, we can discuss it when we meet on Zoom next.